Alright, now we're going to do, I'm going to give you a couple examples here of using the indirect truth table method to test an argument for validity that require more than one line. Okay, so these are indirect truth tables that require multiple lines, as many as 3, and sometimes you can have an argument where you only need to do 2 lines. Okay, so let's read this here, and this will all make sense. You're going to encounter certain arguments where a single row of truth values is not sufficient to prove an argument valid. With these type of arguments, you have to list all of the possible ways that the premises can be true or premise, and the conclusion is false, and proceed from there. You know, up to this point in the first part 1 of 6.5, you remember the conclusion was a conditional. Well, there's only one way a conditional can be false, so we lucked out. It's one-liner. But what if you have a conditional that's like a conjunction? There's 3 ways a conjunction can be false, and you have to test all those three different lines to see if you can go backwards on each one of them, or if they all will contradict, right? So this is giving you a little clue of why we need to sometimes do more than one line. Okay? If an indirect truth table requires more than one line, then pick one of the premises or the conclusion that will require the indirect truth table to be done with the fewest amount of lines. Up to this point, we've just said, you know, true premises, false conclusion. We've started with the conclusion and worked backwards, right to left. Well, when you know there's more than one line involved, then you don't necessarily have to start with the conclusion. If a conclusion can be false 3 different ways, like a conjunction, and you have one of the premises that's like a biconditional, and remember with a biconditional, here's this little chart again. Here's a biconditional on this chart. A biconditional can be true 2 ways. So start with the premise and just have to go through 2 lines instead of starting with that conclusion where you have to fill in and go backwards and work with 3 lines. Okay? So up to this point, we've always just started with the conclusion, right to left. Sometimes, though, you could go ahead and start with the premises if the premises are true in less lines than the conclusion is false. Okay? So let me read this just to reiterate again. If the premise can be made true in just 2 ways, and the conclusion can be made false in 3 ways, then go with the premise and work with just a 2-line indirect truth table as opposed to a 3-line indirect truth table. If neither situation prevails, then go with the conclusion and work from right to left. So let's say there's 3 ways the conclusion can be false, and there's 3 ways all the premises can be true, then go ahead and work with the conclusion and go right to left, okay, as a matter of convention maybe. Now, when you have multiple lines, though, you have to be a little careful. You can only stop, you know, you try the first combination, you try the second, the third. You may have to go through all 3. You're only allowed to stop if you get a line where the bad line works. All you have to do is find one line where you can fill in backwards with no problem. But if the first line contradicts, all it's telling you is that line is not tolerating a bad line. That argument's not tolerating that bad line. It doesn't mean it's valid. The only way you'll know it's valid, every single possible line, the other 2, have to come up with a problem or a contradiction. All you have to find is one line that's a bad line that fills in nicely for the argument to be considered invalid. Just because your first line is a contradiction doesn't mean the argument's valid. You have to go through all lines, and they all have to come up with a problem. Okay? So let me just reiterate all that here. You need to make sure all possible lines lead to a contradiction in order to know that the argument is valid. For example, if the first 2 lines lead to a contradiction and the 3rd line does not, then the argument is considered invalid, because all you have to do is just find one line where the bad line is tolerated. Remember, in a truth table, you just had to find one line. Even though the other lines in a truth table didn't have true premises, false conclusion, if you just found that one, that's all you needed to determine that the argument was invalid. Okay? Start with the first line on multiple lines. If you encounter a contradiction, you've got to go to the next line and the third line. They all have to contradict for the argument to be valid. But if you start with the first line, it's a contradiction. Go to the second line. Let's say there is no contradiction. It's invalid. Let's say you have 3 lines. First line contradicts, second line contradicts, third line doesn't contradict. It's invalid. You have 3 lines. Let's say you do the first line and the bad line works fine. There's no contradiction. You don't have to go any farther. The argument is invalid. Okay? So right here we have an example. I've already written this down, and we'll put this over here. And let's do this one. Okay, so pay attention here as we look at this. Here's why we need more than one line. Remember, the conclusion has to be false, right? So here our conclusion, here's the double slash, is a conjunction. How many ways can a conjunction be false? A conjunction can be false 3 different ways. So if you pulled this out and you went to the conjunction table, there are 3 different combinations of true-false values that make a conjunction false. So if we want this conjunction to be false, that requires 3 lines. Now, you remember I said, let's check the premises. Maybe there's a premise where, you remember, all the premises got to be true and the conclusion's got to be false. Well, what if one of the premises, it could be true only one way, like a negation. But there's no negation here for the main operator. This is a conditional, this is a conditional, this is a conditional. Remember, premise 1, this is premise 2, this is premise 3, and here's your conclusion. But since the main operator for all premises are conditionals, there's 3 ways a conditional can be true. Here you're looking at true, right? All the premises got to be true, but conditionals are true 3 different ways. The conclusion is false 3 different ways. So since it's equal, go ahead and start with the conclusion and work right to left like we were doing, with the other examples that are only required 1 line. So let's go ahead and write false here, and false here. It's a multiple line truth table. And let me go ahead and circle these. All right. And what are the different ways that a conjunction can be false? Well, A can be, if we go to our little yellow sheet here, and you look at the definition of the operators for a conjunction, you could have P be true and Q be false. Now remember, it has to be under the main operator, so not B is the P, so it has to be false under this, tilde. So you have true, false, and I'm just looking at the definition of the operators. False, true, again, under the main operator, and false, false, right? Remember, a conjunction is only true when both P and Q are true, and it's false every other time, okay? So we got true, false, false, true, false, false. And remember, the premises all have to be true, right? True, true, true. And I'll go ahead and circle that, and we'll just do this first line first. Remember, we have multiple lines. Maybe we'll find out this first line, you can go backwards and it works, then we know it's invalid and we can stop. But remember, if you get a contradiction, you can't stop, you have to keep going. But let's try this first line, okay? So A is true, B has to be false, right? Let's go to red now. So B has to be true. If B is true, then not B is false, and then so B is true, and A is true. So this makes not B false. And true, false, we already have a contradiction. Makes the conditional false, but here it's supposed to be true. So right there we have a contradiction. Okay? And so, but we have to keep going. Remember, just because you have a contradiction doesn't mean you can stop. You can only stop with multiple lines when you have a line that works. Okay, so at least we know this line is not working, but this doesn't mean we know for sure yet the argument is invalid. So let's go to the next one. If P is false, which is the A, and Q, which is not B, is true, that'll make a conjunction false. So B here has to be false, so not B can be true, right? So we'll make B false. Okay. A is false, so we're on the second line. A is false. So not B becomes true, and false true for a conditional is true, so that worked. Okay, B is false. Right here, A is false. And so if we have false, false for a conditional, that makes it true, so we're okay. Okay there. And then let's go to the one over here. We're still working on the line. So far we're going backwards and everything's working. Remember, B is false. A on this second line is false. Remember, we're already done with the first line. A being true, B being true. Now we're dealing with A being false and B being false. So here's B false, A false. We've got to change this to true. So not A is true and B is false. That's like the P and the Q. That equals false. So we've got a problem. It contradicted there. But remember, if you reach a contradiction, you still have to go to the final line. We don't know yet this is valid. All we have to do is find one line where everything's hunky-dory. The only time you can stop, you stop when you get a line where you can fill in backwards, starting with the bad line, and everything's fine, and there's no problem, and there's no contradiction. But we haven't done that yet. So we had a problem here. We had a problem here. Now we're going to go to the third and final line. The third and final way a conjunction under this situation can be false. Okay, so we have A is false. For not B to be false, B has to be true. Okay, so B is true and A is false. So B is true and A is false. And this means not B is false. Oops, sorry. Let's erase that. We'll make A false there. Okay, A is false. So false, false for a conditional is true. We're fine there. B is true and A, wait a minute, B is true and A is false. Right, because these are initial values. A is false, there's A. B is true. So true, false for a conditional is false, but it's supposed to be true. So here we have our contradiction. Okay, it happened in the middle here. So this line contradiction, contradiction, contradiction. Therefore we know this is a valid argument. Okay, I'm good. So I did not tolerate any bad line. Okay? So the argument is valid. Okay? Because it didn't like any bad line. Okay. Let's go to this example down here. This is going to be kind of tricky, but now this is going to turn out to be a two-line one, and we're going to start with the premises. So we're going to go through this, and I want you to pay attention here, okay? First, we've got to decide if we can do this in one line, or we're going to need multiple lines, okay? So remember, the conclusion has to be false. So, and remember, it has to be under the main operator. This is a negation. It is not the case that if I then H, okay? Neither I, it's not the case if I then H. So inside the parentheses has to be true, right? Inside, so let's go over here. Inside the parentheses, it has to be true in order for underneath the main operator to be false, right? So how many ways can a conditional be true? 3 ways, because you have to have it true inside the parentheses in order for, under the main operator, this conclusion to be false, right? So we're dealing with 3 lines, so you've really got to pay attention. This one's a real good example. Inside the parentheses has to be true, so then the main operator, it is false, because this conclusion has to be false. So that's 3 lines if we start here. Now in the biconditional, since we have a negation here, underneath the main operator of the premise has to be true, which means inside the parentheses it has to be false. Well, how many ways can a biconditional be false? And if you again look at your, you have a list like this in the back of your book. If I go to the biconditional, there it is. There are 2 ways that a biconditional can be false. Just 2. So if it's false here, it'll be true. So this is going to be, we can make this a 2-line indirect truth table. And here we did something different. We're going to start with the premises, okay, and go left to right. Where before we always started with the conclusion here. You remember, if it's equal on either side's multiple lines, go ahead and start with the conclusion, go right to left. But here, heck, I've got a little bit of laziness in me. I'd much rather do a 2-liner than a 3-liner. So what you do is write down how a biconditional can be false, okay? And it can be false by P being true and Q being false, or by P being false and Q being true. Remember, the I, if and only if J, the I is the P and the J is the Q, right? So true, false, false, true. All right, so why don't we just go and start working through these, okay? So this is makes it false. If you have true, false, the biconditional becomes false, and then this, negating it, becomes true, right? And that's what we're trying to do. So actually, in the beginning, before I started, I should do this. We're going to make the premise true under the main operator. We're going to make the conclusion false. So I should do this in the beginning, okay? And this second line, the conclusion is going to be false. And this second line for the premise is going to be true. So we'll circle these, and we're just going to see if this works, okay? Alrighty. Okay, so when you have true, false, the biconditional is false. Negating it, it's true. That's fine. So I is true. Let's just fill this in here. And J is false. Okay? If I, then J, this makes this false, right? Just looking in the parentheses. If I is true and J is, if you have P is true, Q is false, it makes the conditional false. But this contradicts, because then the negation would be true. Okay, so we have right here a problem. Okay, so we need to go to the next line, right? Remember, just because we got a contradiction, we don't know the argument's valid yet. This one has to come up with a contradiction also. All we need to do is find one line where everything works and it's invalid. So we've got to go to the second one. So with our second line, this time I is false and J is true. This makes the biconditional false, right? Which in the parentheses with the negation, it makes it true. Fine. No problem there. Let's go down to this line. So I is false and J is true, which makes the conditional true. And then when you negate it, it makes the conclusion under the main operator false. So this line right here, no problem, right? No problem. And what does that mean? It means the argument is invalid, right? Argument is invalid because it tolerated a bad line. Sorry, my pen was skipping there. Okay? So even though it contradicted on the first line, it was wide open on the second line, and so the argument is invalid. Okay? And here was an example where we only had to do 2 lines there, and we started with the premise. Okay? So this gets kind of tricky. Remember, with multiple lines, you only get to stop and go no further if you get a line where you're working backwards, the bad line fits perfectly and there are no problems. If you have multiple lines and you have a contradiction, you've got to keep going. You're only allowed to stop when you find a bad line that goes smoothly backwards, or you go through all of the lines, and if they all contradict and have a problem, then you know you have a valid argument. Okay, we'll go to the next thing about 6.5 is using indirect truth tables to test if statements are consistent. We're not going to be using the indirect truth table in those situations to show dealing with arguments. It's just now going to deal with comparing statements. So we won't be using the double slash then, because it's not an argument. It's just statements side by side. Okay.